Well, hello everyone, and welcome to our channel 361 Physics. Okay, so as we have been discussing about the different MCQ related with different topic of physics, so this is the second part of previous video, which is given title as 2000 plus MCQ. So this is question number 26. In previous video, we have already done a discussion up to question number 25. So let us begin with question number 26. Okay, so let us read it first. A drum of radius r and mass m1 rolls down without slipping along an inclined plane of angle theta. Okay, the friction force, okay, there are several options: dissipates energy as a heat, decreases the rotational motion, convert translation energy into rotational energy, and decreases rotational and translation motion. Okay, so from the question we are clear that it is based on the rotational dynamics. Okay, so here the question mentioned that a drum is rolling without slipping, which means that the frictional force acting between the inclined surface and this particular drum uh, try to maintain the circular motion or rotational motion of this drum. Okay, so there is no uh, translation motion. Okay, so that means it is mentioned here that the drum is rolling without slipping, which means that there is uh, there is a kind of rotational motion, and this rotational motion is provided by the frictional force acting between the inclined surface and this drum. That's why we are here confirmed that the frictional force acting between or just the frictional force converts translation, you can say it as energy or motion into rotational motion. Okay, so फेरि एकचोटि भनिदिउँ, यहाँ इन्क्लाइन प्लेनमा एउटा ड्रम रोटेट हुँदैछ र ड्रम रोटेट हुँदाखेरि के हुन्छ भन्दाखेरि यहाँनिर प्योरली स्लिपिङ, यस विदाउट स्लिपिङ भन्ने वर्ड युज गर्नुको मतलब के छ भन्दाखेरि यहाँनिर ड्रम मा रोटेशनल मोसन छ। रोटेशनल मोसनको कज के हुन्छ भने जस्तो इन्क्लाइन प्लेनमा एन्ड एउटा अब्जेक्ट रोल हुँदैछ भने त्यहाँनिर प्लेन र यो सर्फेसमा फ्रिक्सनल फोर्स एक्ट हुन्छ र यो फ्रिक्सनल फोर्सले के गर्छ भन्दाखेरि फ्रिक्सनल फोर्सले यो बडीलाई, यो अब्जेक्टलाई फर्दर रोटेसनलाई हेल्प गर्छ, रोटेसनको लागि हेल्प गर्छ है। त्यसैले गर्दाखेरि हामी के भन्न सक्छौँ, अप्सन सी करेक्ट अप्सन देखिन्छ। ओके, सो दिस इज अल अबाउट 26, क्वेसन नम्बर 26. नाउ वी आर गोइङ टु सल्भ or discuss question number 27. If the earth suddenly shrinks to half of its present radius, mass remains unchanged, the value of acceleration due to gravity at its surface will be, okay. So as we know that acceleration due to gravity is inversely proportional with the radius, square of the radius, and condition is m is constant, m remains constant, which means that if the radius decreases, acceleration due to gravity will surely increase. Then from this particular question we have to replace this radius by one half, and it will be here as 4 and it will go here, which means acceleration due to gravity becomes 4 times of original value. Okay, so our option will be option B. Okay, so फेरि एकचोटि फेरि यसमा पनि डिस्कसन गरौँ। एक्सलेसन के भनेको छ भने अर्थ चाहिँ आफ्नो ओरिजिनल साइजको एक्ज्याक्टली हाफ साइजमा श्रिङ्क भयो भने, श्रिङ्क मिन्स खुम्च्यो भने, एक्सलेसन ड्यू टु ग्राभिटीमा के मोडिफिकेसन हुन्छ, इज देयर एनी चेन्जेस इन एक्सलेसन ड्यू टु ग्राभिटी अन इट्स सर्फेस भनिरहेछ है। सो हामीले बुझ्नु के पर्छ भन्दाखेरि एक्सलेसन ड्यू टु ग्राभिटी इज इन्भर्सली प्रोपोर्सनल विथ द स्क्वायर अफ रेडियस अफ अर्थ अर एनी प्लानेट प्रोभाइडेड एम रिमेन्स कन्स्टेन्ट। अब यहाँ हामीलाई के भनेको छ भन्दाखेरि क्लियरली हाफ अफ इट्स ओरिजिनल भ्यालु भनेपछि त ओभरअल जस्तो यो आर रेडियस थियो भने यसको हाफ अब श्रिङ्क भइसकेपछि रेडियस नै हाफ टाइम्स डिक्रिज भयो होइन। त्यसले अब यसलाई हामीले एमसिक्यू प्याटर्नमा सल्भ गर्दैछौँ, त्यसले अब यहाँ के गर्न सकिन्छ भने एक्सलेसन ड्यू टु ग्राभिटी इज इन्भर्सली प्रोपोर्सनल विथ स्क्वायर अफ द रेडियस र रेडियसलाई हाफले रिप्लेस गर्यो, हाफको स्क्वायर 1/4 हुन्छ, 1/4 यो यहाँ मल्टिप्लाई हुन जान्छ यो पोइन्टमा, त्यसैले हामी के भन्छौँ भने एक्सलेसन ड्यू टु ग्राभिटी विल इन्क्रिज बाई 4 टाइम्स अफ इट्स ओरिजिनल भ्यालु। ओके, सो option B is the correct option for this question. Question number 28. If radius of Earth's orbit is made 1/4, the duration of time period will be or will become. So यहाँ म एउटा फर्मुलेसनको कुरा गर्दैछु। This formulation is known as T3 law, and according to T2 law, according to T2 law, square of time period is proportional with the cube of the radius. Okay, um, so we can say that square of time period equal to k times suppose this to be any constant rq. Yeah, and then let us go to question, and here it is given that the radius of Earth orbit is made 1/4. Okay, so suppose at initial case the time period is t1, and after decreasing the radius its time period becomes t2. At this particular position the radius is r1, and at this position the radius is r2. Then we can generate one relation t1 by t2 whole square equal to r1 by r2 whole cube. Okay, which means that we can write this formula as t1 by t2. Okay, t1 by t2 whole square equal to r1 by r2 can be replaced as 1 by 8 time. Okay, 1 by 4 times. So in the place of r1 by r2 we can directly use here, in the place of r1 by r2 we can easily write uh, it as the value 1 by 4, because the radius final radius is 1/4 of original radius. So here I'm going to write 1 by 4, and its cube is here, this is 2 square. Okay, now we can write t1 is to t2 as 1 by 4. Okay, and then let's do directly here the cube of 4 we can write here 3 by 2, and its 4 power is also 3 by 2. Okay, now we can write it as t1 is to t2 equal to 1 by, and this will be here 1 4 cube sorry, I'm going to write the value directly here. So this is 4 cube and whole power 1 by 2, 1 by 2. And what about the 4 cube? The value of 4 cube is here, we can write this to be 64, and its square root, which means that its value is 1 by 8. So time period will be 1 by 8 times is the proper answer. Okay, so this is a lengthy process. Now if we want to solve it quickly, then just use this particular relation t square k times r uh, rq. Okay, now t, um, uh, just generate one relation. So t2 by t1 will be here r by r1 by r2, and it will be 3 whole whole power 1 by 2, and then just replace r1 by r2 with 1 by 4 and solve it, and finally you will get the answer 1 by 8 times. Okay, so this is all about the question number 28. Well, we are now heading towards question number 29, and in the question number 29 it is said that the weight of an object in coal mine, sea level, and at the top of the mountain is W1, W2, and W3 respectively, then which is correct? So as we know that weight is the product of m and g, that means mass with acceleration due to gravity, and also we know that the maximum value of acceleration due to gravity is on the surface of earth. As we move upward, or as we move downwards, or from the surface, then acceleration due to gravity will reduce. Okay, so we can easily say that acceleration due to gravity at surface is more as compared to the coal mine and uh, coal mine and on the top of mountain. Okay, so we have to find the proper order, which means that if W2 represents the um, weight of any object on sea level, so surely this will be greater than the value of weight on the top of mountain, and value of weight on uh, inside a coal mine. Okay, so proper order will be like W2 will be greater than W3, as well as W2 is greater than W1. So our correct option, let us find this order, and this order is given here in question number A. That's why question number 29 uh, has correct option, and the correct option is option A. Okay, so this is all about question number 20 now. Now we are heading towards question number 30. The average density of Earth is directly proportional to Z, is inversely proportional to Z, does not depend upon Z, and complex function of Z. Well, so let us write the expression for Z in terms of density. So as we know that mass is the product of volume into density, and this is R square G. So for a given radius and for a given volume, and this is of course constant, so we can confirm that G is proportional with density. G is directly proportional with the density. So our correct option will be average density of Earth is directly proportional with to the G. Okay, so option A is here is the correct option. Okay, that was question number 30. Now we are going to discuss question number 30 first. A planet in a distant solar system is 10 times more massive than the Earth, and its radius is 10 times smaller. Given that the escape velocity from the Earth is 111 km per second, the escape velocity from the surface of that particular planet will be, well, so first of all, we have to know the expression of the escape velocity on the surface of Earth is root under 2gr, and we have to replace this g in terms of mass and radius, because the comparison, sorry, we have to compare in between mass and radius. Okay, so here I'm going to replace this as gm by r square, and this is just r. Well, I'm going to cancel out this. Here is square root, so this will be 2gm by r. This is another kind of expression for escape velocity. Okay, now what is given here? The mass of uh, that particular planet is 10 times more, and radius is also 10 times, sorry, radius is 10 times smaller. So here I'm going to write uh, p equal to 2g, and this is 10 m. Okay, 10 times of mass of earth, and here r by 100, this is sorry, not 100, sorry, 1 r by 10. So on solving, it will be, it will go here and it will make 10 into 10, that means 100. And if we take uh, 2 outside the root, then the expression will be 2gm by r, and this is what, this is the expression for the uh, escape velocity on the surface of earth. So its value is 11. So we are here, uh, we can write here 11 times 10, that means 110. So escape velocity on that particular planet is 110 kilometer per second. So this is question number 31. Now we are going to solve question number 32. Okay, so अब यसमा केही भन्नुपर्ने हुनसक्छ, जस्तो हामीले यहाँनिर के गर्यौँ भन्दाखेरि स्केप भेलोसिटीको एक्सप्रेसन लेख्यौँ, एन्ड देन आफ्टर त्यसलाई हामीले जिएम बाई आर स्क्वायरको फर्ममा लेख्यौँ, बिकज हामीलाई प्यारामिटर्स नै त्यस्तो दिएको छ, मास दिएको छ, रेडियस, सो मासलाई इन्क्लुड गर्ने एक्सप्रेसन हो, एन्ड देन फाइनली यो एक्सप्रेसन पायो हामीले स्केप भेलोसिटीको लागि, एन्ड देन हामीले दिएको फर्मुलेसन, सरी, भ्यालुजहरू यहाँ युटिलाइज गऱ्यौँ, एन्ड फाइनली हामीले 10 टाइम्स ओरिजिनल अर स्केप भेलोसिटी अन द सर्फेस अर्थको 10 टाइम्स पायो, जुन 11 किलोमिटर पर सेकेन्ड हुन्छ, एन्ड देन फाइनली मल्टिप्लिकेसन गऱ्यौँ, एन्ड देन रिजल्ट 110 आयो है. Okay, so question number 32. The mass of earth in terms of g, m and r is. So this is quite easy, because as we know that g equal to gm by r square, here is the, this is what, mass of earth. So I'm going to rearrange this in terms of g r by and capital G. So proper option is option first. Question number 33. If the earth suddenly stop rotating, the weight of body on earth's surface would be. So as we know that acceleration due to gravity uh, can be written as g minus, okay, omega square r and cos square theta. This is uh, latitude effect. Okay, so as question said that omega is 0, that means earth stop to rotate, which means that overall this value will be 0, and g dash becomes equal with g, that means there is no change in the acceleration due to gravity. So option D is correct option. Okay, that was question number 33. Now we are going to solve question number 34. Question number 34. Let me change this. Now this is question number 34. Young's modulus. Okay, this is related with elasticity. Young's modulus of elasticity for the perfect elastic body is. Okay, so as we know that the value of Young's modulus depends upon the ratio of stress to the strain, and from the definition uh, we know that the body are said to be more elastic if we required more or extremely high force to deform its shape or configuration, or in another word, we can say that those objects which do not show any kind of deformation by applying large amount of force are known as more elastic. So we know that uh, for uh, perfectly elastic body, the strain or simply strain, that means change in length per unit original length, the change in length must be zero. Okay, which means that strain must be zero, and using this value here we get gamma or y to be infinite. So we can conclude that for Young's modulus for perfectly elastic body is always infinite. Okay, now we are going to discuss question number 35. A fixed volume of iron is drawn into a wire of length L. The extension produced in this wire by a constant force F is proportional to. Okay, so I'm going to discuss it. It is given that a wire is formed by stretching uh, stretching a fixed volume of iron. Okay, so I'm going to write here first of all the formulation related with the Young's modulus, which is equal to force per unit area, that means this is stress, and strain, that means change in length, or we can say this to be extension, here is given here. So x by original length, and now we have to interrelate the force, okay, force with length, because the extension produced in this wire by the constant, oh sorry, we have to interrelate the extension with the length. So I'm going to write here x as, see here, f times L by a times gamma, and for given wire and for given constant force, these two parameters are constant, these two parameters. So we can write this expression as some constant time L by A, and it is given here for a given volume, which means that um, volume is constant, but area cross section of course changes, because on drawing a wire the radius will definitely decrease. That's why we cannot use E or area as a constant parameter here. So we have to express the area in terms of volume and length. Okay, so as we know that uh, volume is a product of area and length, so area can be written as the ratio of volume to the length. So here I'm going to utilize this, and on using this value here we'll get x equal to k L square by b, and from the question b is also constant, so we can get our result, which is uh, that is x is proportional with the square of length. Okay, so extension produced in the wire is directly proportional with the square of length. Now we are going to discuss question number 36. A wire fixed at the upper end is stretched by length L. By applying a force F, the work done in stretching wire, so this is quite direct question, because we know that work done on stretching wire is equal to half F into extension. So our option D is correct option. Question number 37. Young's modulus for a perfectly plastic bodies is, okay, so for perfectly plastic bodies, which means that if we apply a small force, the strain will be high in generally plastic body, and in ideal case for a plastic body the strain must be infinite. Okay, so which means that if we apply small deforming force, it will cause a large deformation in an object, then that particular object is said to be plastic. Okay, so in ideal case uh, we are going to suppose that plastic bodies are those bodies in which strain is supposed to be infinite. Okay, so and also Young's modulus is the ratio of stress by strain. So as strain is infinite, so Young's modulus must be 0 for a perfectly plastic body. So here the option A is correct option. Okay. Now we are going to discuss question 38. Two wires of same materials and same radius have their lengths in the ratio 1:2. If they are stretched by the same force, the strain produced in two wires will be in the ratio. Okay, so let us develop one particular relation and then we can confirm our answer here. As gamma is equal to F by A, that means force per unit area, and change in length per unit original length. Okay. And this is what strain, so I'm going to write it as strain, and from here we can get one particular expression here, F by A, and this is gamma. Okay, now from this particular relation we can see that strain depends on the force area of cross section, and this is what Young's uh, modulus. And from the question uh, we are given that stretched by the same force, that means force is constant, having same material, which directly says that gamma or Young's modulus is constant, and strain depend upon the area. There is nothing mentioned about the area, so we can say that this all parameter is remains constant. Okay, and strain is independent of original length. Here there is no particular uh, parameter which include the length, so we can confirm that strain in both the wires will be same. So our option A is correct option. Now we are going to discuss question number 39. ML inverse T minus 2 represent the dimension of stress, Young's modulus, bulk modulus, Poisson's ratio. Okay, so let us discuss this. Here ML inverse T minus 2. Now here if we write it as ml t minus 2, and I'm going to divide it by l minus l square, so of course uh, it is the ratio of f upon uh, area. Okay, so force per unit area is the unit of Young's modulus or stress. Yes, so except this Poisson ratio here, uh, stress has the same dimension, Young's modulus also has the same dimension, so uh, and as well as the bulk modulus also has the same dimension. That's why except D, A, B and C, all three are the correct option. Okay, so here we are going to take all of these. Now question number 40. The breaking force of a wire depends on breaking force. So as we know that Young's modulus is force per unit area. This is we can suppose to be breaking force, because if we go on increasing the force, ultimately any kind of wire will break. So force per unit area, and this one is original length per unit length per unit original length, change of length per unit original length. Okay, so I'm going to express it as the force as uh, okay, so it will be here. Let me write in proper way. Okay, so it will be del L by L gamma, and then after I'm going to write here A, and this is F. So um, there are two options if you see minutely: material of wire, length of wire, radius of wire, shape of cross section of wire. So among them we have to find the proper option. So from this discussion we are clear that force or braking force depends upon gamma directly, which means that braking force is a material dependent force, and this also depends on the area of cross section, and area of cross section ultimately depends on the radius of uh, any wire. So radius of wire and material of wire are the two parameters on which the braking force depends. Okay, so these two are two parameters, and this is the strain, and strain also depend on the Young's modulus, or we can say that strain is constant for a given material. So of course uh, this can be treated as the constant. So braking force depends on gamma and area, and indirectly we can say that braking force depends upon the material and radius of the wire. Okay, so this is the solution for question number 40. Now we are going to discuss the question number 41. A weightless rubber balloon has 100 gram of water in it. Its weight in the water will be. Quite interesting question. Okay, so mm, we have to think about this question, because here we have to find the weight of water on water. Okay, because we have to ignore the weight of the balloon, weightless rubber balloon. So from Archimedes principle, we can get the idea how does the weight of any substance changes when we place that particular substance in any liquid or water. So let us discuss first that particular thing. See here, this is a spring balance, and I'm going to attach something here. This is in air. Now suppose this pointed is here, and it indicates somehow 20. If we place the same material, same object in any liquid or water, okay, due to off thrust, upward force, it will force the object upward direction, and that's why this pointer will move upward, and due to this motion it will read less as compared to the previous case or when the object is in air. Okay, so that's why the weight of object appears to be less in any liquid, and due the reason is that that is the liquid will exert upthrust. Okay, so due to this particular upward force, the weight of any object in any liquid will decrease. Okay. Now we are going to discuss what will be the effect of water on the water, whether the water exert the upward force on the water or not. If water exert upward force on the water, then of course the weight of that particular water which is inside the balloon will definitely decrease. But as we know that here, upthrust is the product of volume, density, and acceleration due to gravity. we know that. And also the weight of body can be written as the mass into gravity, the product of mass into gravity, and it can be written as, see here, its weight can be written as mg, sorry, and it can be written as p, and rho. Rho is the density of particular this object, and this is what z. And of thrust can be written as b. Suppose density of liquid to be d and c. Okay, so due to difference in density, there uh, is a kind of thrust. But for the case of water, we are going to write b rho z, and for the case of thrust, once again the nature of liquid is same. So of thrust, for of thrust, where we have to write b rho z, which means that this all parameter will cancel out. That means there is no upward force which act on the water inside the balloon. Okay, so the weight or mass of the liquid, water, on the water, in the water is, okay, so we can confirm that the weight of water in water, okay, the weight of water in water is zero. Okay, so weight of water in the water is of course zero because there is no upward force, we can say that. So net weight on the water, of the water in the water is zero because there is no upward force. Okay, even uh, we can, okay, there is of thrust, yes, sorry, there is no upward force, it's not a correct way. There is of thrust which has the same uh, upward push, which is equal to the weight of water. See, better to say this. Okay, so upward force uh, is the off thrust, and the amount of off thrust acting on the liquid, on water, which is placed in a water, is equal to the weight of the water. Okay, so that's why we can say that there is no change in uh, this the value of pointer shown, uh, the value of the pointer of the spring indicates. So we can say that the weight of uh, water in water is zero. Okay, so this is a kind of discussion. uh, so uh, of thrust, the value of thrust is equal to the weight of the water. That's why pointer uh, will move completely in its initial position. Okay, so this is all about this particular discussion, and this is quite important because if you see, there is mention a rubber balloon has 100 gram of water, and ultimately we uh, want to find the weight of water in the water, and of course we are going to use Archimedes principle, and by using Archimedes principle we can easily say that of thrust acts on this particular balloon. Yeah, but the amount of thrust acting in this particular balloon uh, is exactly equal to the weight of the water placed inside the balloon. That's why there is no change in weight. The pointer does not move completely downward. Okay, so the total weight in water is 0. So this is all about question number 41. Now we are going to discuss question number uh, 42. A man is sitting in a boat which is floating in a pond. If the man drinks some water from the pond, the level of the water in the pond decreases, increases, remains constant, may decrease or increase depending on the weight of the man. So this is a kind of uh, question which is similar to that of previous question. It is given that man drink the water from the same pond, and here once again we have to find the weight of additional water which is uh, taken by the man in the water. Okay, weight of the water in the water, we are going to discuss about that. So from the previous discussion we are confirmed that the weight of water in water is of course 0. There is no change in weight. Okay, so that's why we can say that the weight sorry the level of water in the pond remains unchanged, because the reason is same as we have already discussed in 41 number question. The weight of water in water is always 0. Why? Because the upthrust acting on the water is equal to weight of the water. So there is no change in weight, which means that the if we place water, okay, suppose this is water and this is placed inside the water, then the pointer remains on its initial position. That means pointer indicates 0. Okay, so that's why we have to just remember this line: weight of water in water is always 0. Now we are going to discuss question number 43. Two vessels A and B have the same base area and contains water up to same height, but the mass of water in A is 3 times that of B, as shown in figure. The ratio of liquid thrust on the base of A to that of B is. Okay, so we have to find the pressure exerted by the liquid in two vessel on its surface. And as we know that pressure exerted by the liquid is the product of HdG. That means it depends on the height, nature of the liquid, and acceleration due to gravity. It does not depends on the surface area. Okay, so pressure equal to HdG, which means that pressure depends upon height, pressure depends upon the density, that means nature of liquid, and pressure depends upon the G. So we are here to conclude that pressure depends on height, and its height of the liquid column in both the vessels are same. That's why the pressure exerted by the liquid on the base of each vessel is same. That's why the ratio will be 1:1. Okay, so this is question number 43. Now we are going to discuss question number 44. A jar is filled with two non-mixing liquids 1 and 2, having densities rho 1 and rho 2. A solid ball made of a material of density rho 3 is dropped in the jar. It comes to equilibrium in the position as shown in figure. This is figure. Which of the following is true for rho 1, rho 2 and rho 3? So let us discuss first this particular question. See, there are two kinds of liquids and one is solid. As this particular solid is well inside this first liquid, which means that rho 3 is greater than rho 1. And as this solid is floating on the surface of rho 2, that means second liquid, So it means that row 3 is less than row 2. Okay, so here is the common factor is, we can say, row 3. Okay, so on combining these two condition, we can say that uh, row 3, okay, row 3, that means density of object is less than row 2, but this is greater than row 1. So we have to find this kind of order, and this is given in option B. Okay, so that was question number 44. Now we are going to discuss question number 45. Well, so I'm going to shift this page, so it will take small time. So this is question number 44. Now question number 45. This is question number, okay, 45. Well, if there is no gravity, which of the following properties will not exist for liquid? Viscosity, surface tension, pressure, Archimedes upward thrust. So as we know that viscosity, sorry, this is not correct answer. I'm just trying to write here. Viscosity is related with the uh, friction acting between two layers of liquid when they are in relative motion. Surface tension is the property by virtue of which any um, free surface of liquid try to occupy less surface area. Okay, and this is what, this is pressure, and pressure um, exerted by the liquid um, is equal to, I know that P equal to H dz, and due to this pressure, okay, this pressure, upward force also acts, because as we place any liquid, sorry, any object inside a liquid, okay, so there will be a kind of force which act upward. Okay. If there is no weight, see here, if there is no weight of this object, then of course the upward thrust will be 0, though there might be a kind of pressure, because if we anyhow can fill a vessel with some kind of liquid, then of course on the surface there might be a kind of pressure. But if we place any object here, and if the weight of that object is 0, which means there is no upward force. So the proper option uh, is Archimedes upward thrust. Okay, so its answer is uh, option D. Now we are going to discuss question number 46. A piece of ice containing a stone is floating in a water. When ice melts completely, the level of water will decrease, increase, remains unchanged, first decrease and then increase. Okay, so in this question, it is given a ice contains water, and with the water in ice, um, the total here, that the level of water, suppose this is ice and we are placing stone. Okay, this is a kind of question. So overall weight of liquid which displaced by these two system uh, will be more as compared to the weight of liquid displaced by this stone alone, which means that in initial case the height of liquid might be suppose up to here, and in the second case, as the total ice get melted, So the displaced liquid will rise because of this particular stone alone. So we can say that in second case the height of liquid will be less as compared to the first case. Okay, so we can uh, get a kind of conclusion that is a piece of ice containing a stone is floating in a water. When ice melts completely, the level of water will decrease. Okay, so this is question number 46. We are going to discuss question number 47. Which one of the following would a hydrogen balloon find easiest to lift? Okay, so hydrogen balloon, see here, suppose this to be hydrogen balloon and it is going to lift something. So on this process it will of course displace some amount of air. Okay, and its value depends upon the weight weight uh, weight of the object which is attached to this particular balloon. Okay, so weight depends on the product of mass and gravity, and here is in all cases the mass are same, 1 kg 1 kg 1 kg, which means that the weight of this all object will be same. Okay, and finally we can say that the balloon will see the object like steel, water, or lightly packed feather, all will have same kind of weight. So balloon can lift all of them equally in easy way. Okay, so option D is correct option, all the same. Okay, so now we are going to discuss question number 48. Equal weight of two liquids of density rho 1 and rho 2 are mixed. The density of the mixture is. Okay, so there are two kind of liquid, and we have to mix the liquid, and it is given that equal weight. So suppose rho be the overall density of liquid, and m1 and m2 be their individual weights, and v1 and v2 are their volume. Okay, so uh, here I'm going to write this as 2m because total mass uh, equal weight is provided here, and I'm going to replace v1 by m by rho 1 and v2 by m by rho 2. Okay, so we can take these two m as a common, and it will be 2 after cancellation, rho 1 plus 1 by rho 2. Okay, so on solving surely we can get it as rho 2 times rho 1 plus rho 2, rho 1 plus rho 2, this kind of expression, and this is given in question number D. Okay, so now we are going to discuss question number 49. The ratio of pressure of liquid at the depth h on area 1 meter square and 2 meter square is. So as we have already discussed about this, pressure exerted by the liquid is independent of area. Okay, which means that the pressure in both the cases will be same. So option C is correct option. Now we are going to discuss question number 50. Due to capillary action, a liquid will fall in the tube if the angle of contact. So just we have to recall the mercury in this case. Okay, so as we know that mercury will fall or will not show any rise in in any tube or tube made of glass. That's why uh, and also for mercury the angle of contact is greater than 90. We have to know that, and which is also known as obtuse angle. Okay, so in this particular case the option is correct option is option B. Okay, so this is all about question number 50. Now we are going to discuss question number 51. What will be the height of liquid column in the capillary on the surface of moon if it is etched on the surface of earth? Well, we have expression for um, capillary rise, which is equal to 2t cos theta equal to r rho g and h. On solving this, we can confirm that height is inversely proportional with this is gravity. And also we know that a gravity on moon is 1 by 6th part of the gravity on the earth. So from this discussion we can say that height as gravity is 1/6 part of the gravity on earth, so height will be 6 times more as compared to the height of the liquid uh, in a capillary tube on the surface of earth. Okay, so option C is correct option. Now we are going to discuss question number 52. Discs of paper of radius r is floating on the surface of the water of surface tension T. Okay, then force of surface tension on disc is, well, here this is disc. Disc means this all part is completely covered, which means that the surface tension will act along its circumference. Okay, and its circumference is 2 pi r, and we have to find here the force of surface tension. So we know that surface tension equal to force per unit length in general, and here force can be written as product of surface tension times length, and in this case the length is the circumference of this particular disc. Okay, that's why our answer will be T times 2 pi r, and it is given in option B. That's why we can say that option B is correct option for this particular question. Okay, so we are going to tick here option B. Suppose in this question it is said that a ring a ring of uh, metal or any kind of substance of radius this is floating on the surface of water, and then find out the force of surface tension. In that case we have to think about this condition. For ring there are two free surfaces, one inside and another outside. Okay, so surface tension, the force due to surface tension act along both of these sides. Okay, that means surface tension will act inward as well as outward of for the ring. Okay, this is for the ring. In that case we have to apply the relation force equal to T times 2L, because it will have 2 times of length. Okay, so here will be correct answer 2 times of 2 pi r for the case of ring. Okay, this is correct for the case of ring. Okay, so this is all about question number 52. Now we are going to discuss question number uh, 53. A beaker of radius 15 centimeter is filled with a liquid of surface tension this much. The force across an imaginary diameter of the surface will be. So next we have to use the formula. force is equal to T times and diameter, or you can say length, and just put the value of surface tension here 0.075, and then diameter, radius is given, we can just convert it in meter. So I'm going to write it as in this form, 2 times of radius, and radius I have expressed in meter. Okay, so now we can easily solve this, and on solving we'll get the correct answer. Okay, so this is solution for question number 53. Try yourself and write its correct answer in our comment box. Now we are going to discuss our uh, question number 54. Okay, so let us discuss it. Okay, so in this question it is said that a big drop of radius r, okay, a big drop of radius r is formed by 1000 small droplets, okay, so of water, then the radius of small drop is. So on solving this, just use the concept of conservation of mass, or in most of the book it is uh, said that conservation of volume. Okay, so we can say that uh, the conservation of volume um, implies that V1 and V2 are equal. That means volume of large drop and volume of small drop remains constant, because on combined small drops a large drop is formed. Okay, so uh, this is concept of conservation of volume, but in my personal view it must be conservation of mass, because total mass of substance here remains constant. So from conservation of mass as well, we can write the expression as v1 by v1 rho and v2 rho, and I'm going to cancel it. Okay, so once again we are uh, dealing with the same conservation, that means conservation of volume. Okay, so v1 equal to v2, and there is a number is given. So I'm going to suppose v2 as volume of small droplets. So the total volume of small droplets is equal to 1000 times of volume of single drop. Okay, so for v1 we can easily write 4 by 3 pi capital RQ, and for v2 4 by 3 pi small rq times 1000, and these all will cancel out here, and it will be rq, and I'm going to write 1000 and adds 10q, so r will be equal to r by 10. So our correct option is called option D. Well, this is our last question for this particular video. We are making a lots of video related with different topics, okay, of physics, which we think surely be helpful for all of the students who are in 11, 12, and who are preparing their upcoming entrances. Okay, so either they are in medical or engineering or any kind of field in which there is a certain question related with physics. So all of them can get a kind of benefit from our video. So please subscribe us and stay tuned, and please comment in our comment box uh, which topic would you like to uh, understand. We can make a different discussion video as well. So please stay tuned and subscribe our channel. Thank you for watching us and listening us.
and subscribing us. Thank you.